Welcome to the Midi Quest XL Instrument Creator video tutorial. You open the Instrument Creator either by clicking on the Instrument Creator button or by going to the Utilities menu and choosing Instrument Creator window. Now the Instrument Creator window is where you create the individual drivers that do all the bulk communicating between Midi Quest and your instrument, and then these individual drivers are grouped together to create an instrument module. Now when you open up your Instrument Creator, you'll see a pane like the one here. Down the left will be a list of your currently installed instruments. Now on my computer I have every instrument installed, so I have a rather large list. Yours will be probably much smaller, and your window will load much more quickly than mine will. So if you want to look at a particular instrument, it's just a matter of finding it in the list, and I'm going to find the Korg M1 in the list. When you click on the M1, you'll see two things happen. First off, the list will expand and you'll get all of the drivers that go into making up the Korg M1 definition listed. If you're working on a Mac, you'll need to click on the expander triangle to get this list. And on the right hand side, you'll see a whole selection of parameters. These parameters all go into defining the instrument as a whole. And a lot of these are related to how you see the instrument presented in the studio window. So what you have is the instrument name, Korg M1, the folder that all of the instrument definition files are found in, and in this case it's the M1, the bitmap. Here, let me load up the Korg M1 here as well. There we go. So the bitmap is this bitmap you see here, and its file name is M1BMP. And lastly is a style icon. Now these were used in Midi Quest version 8 and 9. They are currently not being used in Midi Quest version 10, but they may be used in the future, and this defines what kind of mini icon to use for the instrument that best represents the instrument as a whole. So you've got a series of keyboards in different colors. You know, if you had an OR lead, then you would probably choose a red keyboard instead of the M1, which we'd choose as a black keyboard. There are rack mounts in various colors, generic modules in various colors, large instruments, and console and floorboard type graphics that can use to be generally visually describe the instrument. Here is a list of the drivers. Now these are all of the drivers that go into making up the M1 module definition, and if you look here, you will see that that is the exact same list as here. The difference is these are the file names as the files are stored on disk, where here what you're looking at is the name assigned to each of those drivers. In this quadrant you have sets. You should be familiar with sets right now. By default you usually get a default set. If I click on default set, you'll see down here again is a list of all of the files, the driver files that go into making up the instrument. You'll see this list, and this list is identical. And the highlighted entries are the elements that go into making the default set. So there's your default set, there's your card set, there's internal plus card, internal plus the internal 50 only banks, and so on. You can have instruments with a lot of different sets. You can have instruments with frequently just one set. And in the lower area, you have a series of general parameters. The first four are GUIDs that are necessary for the Midi Quest plugins in version 10 to work. Now, you should always use the new GUIDs button to generate these GUIDs so that they're created properly. For existing Midi Quest instruments, you should not change these numbers, or you will find that plugins that you created in the past for an instrument will no longer work because the GUID references have all changed. If you create a new instrument, make sure you assign new GUIDs, or they will conflict with existing instruments if you, say, copied the M1 to make the M1 XT new version. Device type, there are three options: mixer, synth, and effect, and this is necessary for Yamaha's Studio Connections plugin format in order to correctly categorize the type of device we're working with. You also, for Studio Connections, need to define two graphics in the PNG format. Each graphic should be 96 bits high, 96 bits wide, or pixels. And you can store a version number for this particular instrument. So how do you go about starting to create? Well, if you want to create a variation on an existing SoundQuest instrument, then what you're going to do is go in, add any new drivers. To add a driver, you can simply type in the name, hit the button, and there's the file name of the additional driver you want to use. You find that it's also listed here as a new entry in the list. If this driver doesn't actually exist, when you go to edit it, you will get a blank initialized driver. If you want to remove a drive, if you want to remove a driver, just select it, hit delete. You can also rename drivers. Simply select the one you want to rename, give it a new name, and hit the rename button, and you're done. You can also change the order in which these entries are found simply by selecting one and hit the up button to move that entry up, or down to move that entry down. Sets, if you want to create a new set, type in the name you want, say my new set, hit the add button. It will be added to the bottom of the list. You can select it, and now you can assign the elements that you want to be part of that set. It's really easy. You can, if you want to make that the primary set that you want to use, just move it up to the top, or you can move it down to the bottom. If you want to delete it, again, just select the set you want to delete, hit the delete button. You want to rename a set, select it, type in a new name, and hit the rename button. And you've seen selection of set elements covered. If you want to change elements in a particular set, just choose the set you want to alter. The elements that are currently components in that set will be highlighted. Click to unhighlight, or click again to highlight. I believe this covers everything that goes into making up a set once you have your drivers. Now, if the drivers are another matter, here's your list of drivers. They're also listed here. click on any one of these and you'll find that the entire right pane changes. This is the window where you completely define one of Midi Quest's. It's called a component in the studio window. From the instrument creator point of view, it's been called a driver for a long time. I still refer to them as drivers. So I can select any one of these, and the definition for that driver will appear on the right hand side. Now this does look like a lot of information, but the drivers do an awful lot. They can really completely control, except for the editors, how Midi Quest treats an instrument. So there is a lot of information there, and you'll need to be able to extract this if you want to create your own drivers. Extract this information from the manufacturer's specifications, and you can put it into this window. So let's work with a patch. So let's have a look at how a driver is created. In this area, we have what are general parameters. You've got the make, Korg M1, the model, which is really the kind of data that you're trying to load, which is, say, a patch. Definition is the path to the editor file that you're going to create for this data. In this case, it would be patch.sqt is the editor file, and it's in the M1 folder. Regardless of whether you are using a Mac or a Windows machine, the path divider here should be a slash, as you see in this example. Company ID, in the case of Korg, it's hex 42. If you're working with an instrument that has a 3-digit company ID number, you're going to enter the first digit in this case, which would be 0. The file size is the total number of bytes that you want to receive from the instrument. The header size is the number of bytes between the beginning of the first sysx message you want to receive in this dump and the actual first byte of the data. So the header is the number of bytes between the start and the actual data, the editable portion of the sysx that you want to receive. In the case of the M1, it's 5 bytes. Template V40 is probably a parameter that you will not use, but what it does is it allows you to pass a single value from the driver into the editor. When you open an editor from this patch, the V40 variable in the editor will be whatever is set in this location. Data format. There are a whole series of different data formats that your sysx can be stored in, and this is the list, and you need to select whatever format matches the data you are trying to edit. 7-bit is all data where the range is from 0 to no higher than 127. You have low-high nibble, where you have pairs of bytes that need to be assembled together to make the full value that you want to edit. The first byte of the pair contains the low 4 bits. The next byte contains the high 4 bits. Korg 7/8, which is what we have selected here, that's a format that a lot of Korg instruments use, where you work in 7-byte groups. The high bits from the first 7 bytes are packed together in the first byte, and then the 7 bytes are stored. Check the manual for this one. They're all explained. You have binary ASCII 2, which is used in the TX-802 and a small number of other instruments where you have pairs of bytes that have the actual ASCII number of the binary value that you want to edit. So say if the stored value is supposed to be 7, it would be written first byte 30 and the second byte, which would be visible as an ASCII number 0, and the second byte would contain 37, which is the ASCII representation of 7. ASCII is all the values are stored in ASCII. 14-bit is very similar to 7-bit, except that all the values are using a 14-bit value where the first 7 bits of the number are stored in the first byte, and the second 7 bits are stored in the second byte. High-low is the reverse of this. HR16 is another complicated packing scheme that was developed by Alesis. Look in the manual for this one. VFX Performance, and so on. Each of these, the most common ones that you'll normally find are 7-bit, low-high nibble, high-low nibble, which you'll see here. And Sonic uses the MR45 packing scheme frequently. A lot of the Alesis equipment uses the quadrasynth packing scheme. If you have any questions, contact SoundQuest about the format here. COM channel offset. This is the byte which stores the channelization information if your SysX is channelized. For instance, virtually all Yamaha equipment uses byte 2, where the first byte is 0, the second byte would be, the first byte in the message would be an F0, the second byte would be the Yamaha ID of hex 43, and the next byte is a channel information byte. This tells Midi Quest where the offset is for that. F7 end. Check this. If the end of your received SysX message has an F7, virtually all instruments do this, and it's a good way for Midi Quest to check to ensure that it's receiving data properly. Check this option if the data being sent is of a fixed length, or through a macro command you force the data to be a fixed length size. If the data you're receiving can vary, uncheck this option and Midi Quest will shrink the size of the allocated buffer to match the data. Macro I/O will virtually always be checked. In the very early days of Midi Quest, there were no macro I/O commands. Everything was done through some very simple dump request messages. This is no longer the recommended method of doing things, but it's still there for historical purposes, so macro I/O should virtually always be checked. Bank loop, you'll see right now, is not available because it only applies to bank data. So if I choose a bank, you'll see this option enables. Bank loop enables a set of special bank loading optimizations. I'll come back and discuss this as we discuss handling of macros. So I'll leave that unchecked and I'll go back here to the patch. Vary size is checked when internally you're keeping a fixed length data buffer, but the actual data that you receive from the instrument can actually vary in size. Check this option. It ensures that Midi Quest doesn't throw in an error when it receives fewer than the expected number of bytes. And timeout should be checked if it is possible that the data you are requesting can't be sent from the instrument. Some instruments allow dynamic allocation of patches. You might have a patch 1, 2, 3, no patch 4, a patch 5, 6, 7, no patch 8, 9, 10, and so on. If this is the scenario, then Midi Quest has to be given a chance to bail out, because it will say request patch 4. If there is no patch 4, it will get stuck. Timeout basically says if you don't get data by now, it's not coming. Move on to the next thing that you need to do. Now, the bank area largely covers parameters that control bank editing. Now, even for, as you see, we've got a patch selected, there are still some parameters that you need to fill in. You will notice that bank is not checked. This is not a set of bank data that we're trying to edit, so it's left unchecked. You still want to say that the number of voices is 1. If there is no bank, let me actually step back here. We'll go look at an actual bank editor. In the case of the M1, a bank contains 100 voices. Special case, you can have a patch. If you want to be able to create a library, you need to specify the number of voices here as being 1. In a case where you say don't want to create a library, but you're still looking at a single type of data, say a sequence, specify the number of voices as 0. Voice size. In most cases, voice size is the number of bytes that you need to make a sequential ordering of data. This is the number of bytes that the pointers in Midi Quest are going to advance so that it can show you each of the entries in the bank, and so that when you are editing a bank and moving around patches, this is the number of bytes that you're going to move. Now, in all cases except for the Korg 7/8 series, this is the actual physical number of bytes. In the case of the Korg data, the 7/8 format, it is the formatted number of bytes. So the actual the number of bytes that the manual says the instrument has for editing purposes, disregarding all of the special formatting. Name, offset, and size. This tells you where the actual name is stored within the data. In this case, it's offset 0, and there are 10 characters. Name format will normally be ASCII, but there are exceptions. So for instruments that have special formatting, these are built into the program, D50, Proteus, and so on. You can look at them. If you're not working with this specific instrument, ASCII is the one that's going to work for you. Voice number format controls the numbering within the bank. Normally it's going to be 0, 1, 2, 3, 4, 5, 6, and so on, but you can have other formats. Roland has a number of unusual ones. They have an 8x3 format, so you'll go up it, you'll have groups of 8, where you have 1, 1, 1, 2, 1, 3, and up to 1, 8, then 2, 1, 2, 2, 2, 3, up to 2, 8, and 3, 1, 2, 3, up to 8, and so on. There's a Roland A1 to A64, B1 to B64 format. Line 6 uses another display format. Again, these are all custom. If you aren't working with one of these instruments, stick with the default. Adjust in advance. Have a look in the help file for explanations on these. Voice offset is an additional special parameter that says where the actual voice data is within the larger context of a voice. To give you an example, let's have a look. Kawaii K1, I believe, is a reasonable example. No, that isn't a good example. All right, here we go. In most cases where you have a driver where you create your bank by going through a loop of receiving individual patches. In order to have the editing work correctly, your header size is 0. The symmetry in each patch means that you need to move all of the bytes from the very first byte in your data, offset 0, through to the F7 of the first patch, and so on. This is too difficult to do verbally. Have a look. There are examples in the help file that will show you how this is structured. So voice offset and voice bytes, please look in the manual. Voice number offset works in conjunction with the number format to allow you to correctly sequence the display numbering within the bank editor. Chunk size allows you to control the grouping of your voices within the bank. By default, Midi Quest will put patches in groups of 16, and I can display that right here by opening up a voice bank. There, if you look, a block of 16 and a block of 16. And that is the default behavior if the chunk size is marked as 0. If you enter a different chunk size of, say, 4, then what you'll see is the patches grouped in blocks of 4. The chunk trim parameter, Midi Quest by default calculates a width of each chunk using the number of characters in the voice and the format of the numbering of the voice. Now, in some cases, the size that you want to use may be that the program creates is slightly too large. So for W is Windows, this is the Windows one, this is the Mac one. You can specify a value in here that will shrink the chunk, the displayed chunk width, by this number of pixels in order to get a size that you like better. Names in voice, for most instruments, will be unchecked because the name is actually stored within the data. In the case of older instruments, or in some rare cases with new instruments, there is no name data within the voice itself. In this case, what you need to do is have Midi Quest allocate a name area so that the user or you can type in your own names for each of the patches. When you check this option, Midi Quest will automatically allocate an area of 10 characters per voice so that you can name your own patches. And in-place editing, check the online help for information on that. We'll look at macros last. Channels and bank select information. The COM channel is the channel that the instrument uses to communicate sysx data back and forth on. If the instrument doesn't have a communication channel, then your MIDI comm channel offset here should be set to 0. And you should set your min and max values here to 1. However, if there is channelization of your sysx messages, then here you need to specify what the minimum and maximum range is for this driver, as well as the default value. Most instruments, you'll see that it's 1 to 16. In the case of Roland, you'll normally see that it's 17 through 32. Midi Lock basically tells Midi Quest that the MIDI channel and sysx communication channel have to be identical. So when the user changes one, the other is automatically changed to keep both in sync. That would be true, say, in the case of the Korg M1. MIDI channel default allows you to specify a default MIDI channel for this driver when a new data block is created. This area covers bank select. Now, bank select isn't really used within Midi Quest itself. However, when you are exporting banks of names for use in Cakewalk or Sonar, for use in Steinberg's Cubase, this information is critical for telling the sequencer which bank it is getting numbers for. So you have a number of different options. You can have no bank select, in which case the instrument that you're generating names for is an old instrument, doesn't use bank select, and the Midi Quest will handle this properly when outputting names for the sequencers. Standard, both numbers of both the MSB and LSB are used for bank select, and you need to enter both values. You can specify just output of MSB, just output of LSB, or in very rare cases a patch change message, usually a high order value, is used to change banks instead of an MSB or LSB. I believe currently, as far as SoundQuest drivers are concerned, this option is only being used by Kurzweil. Here, you need to enter for this bank the MSB bank value that will be output as CC0. Here you need to output the bank identifier that which is the LSB and is CC32. Here we have a couple of parameters that control how bank select gets incremented when you're dealing with a bank that is larger than 128 voices inside Midi Quest. Say you've got 256 voices. You can't just output 256 voices to Sonar or to Cubase. They won't recognize it because there is no patch select number beyond 127. So you can use these values, which are explained in the online help, to correctly increment the bank select for large size banks. Options, IDs, and paths. Prepared format. When you're creating drivers on output, you really need to basically correctly format in any header and any tail information. If you don't format this information in, then you need to leave this option unchecked. If you do format it in, then you should check this option, and what it does is allow you to create new banks, new patches, because the driver then knows that on output the correct header and tail will be added to the data so that what goes out the MIDI port is correctly formatted. Roland Handshake. Roland has two forms of standard handshake communication. They're both referred to, one is referred to handshake, one is referred to as non-handshake, although in actual fact both are forms of handshaking. For more detail, just check out the online help. Is apparent should be checked when you're dealing with hierarchical data. We'll jump back here to the Korg M1, which is a perfect example of a hierarchically organized instrument. Here, your upper level is your Combi bank, and your combis select 8 programs or patches, which are here. So when you're creating your Combi bank, you need to say that this is a parent bank because it's a parent of the patches, and in turn, when you go to your patch bank or program bank, then you're going to designate this as a child. These options control parent-child bank editing, which allows Midi Quest to keep the relationship and the links between combinations and patches correctly organized as banks are edited. Check this. Is a ROM bank if the bank you are loading is a ROM bank. That is, you can't send data to it, you can only retrieve patches from it. And check this option if the data you are loading is drums. Midi Quest has AutoSense capabilities. Midi Quest has a fairly sophisticated algorithm that allows it to choose which driver it thinks is the best driver to use to try and to request data, to identify where an instrument is, which ports it's connected to, and what COM channel it's currently set to. Now, what Midi Quest normally does is it looks for the driver that is going to request the smallest block of data so that this can happen as quickly as possible. If you know that the smallest allocated data is not suitable for handling an AutoSense condition, then you should choose which driver here you want the program to use in its AutoSense search and simply check it. And then it will use that driver in AutoSense conditions. COM channel 0 base works with the COM channel settings. Normally what you see on an instrument is the internal channel range is 1 through 16, or in the case of Roland, from 17 through 32. Now in rare cases, but while it displays that way to the user internally, the ranges are actually 0 through 15 and say 16 through 32 in the case of Roland. Now in some cases, EMU being a prime example, the actual number that's displayed by the instrument needs to be exactly the same as what is displayed in Midi Quest, and you check this option in this situation. And the final checkable option here is use in name server. For every bank that this option again is used only when outputting names to a file for use by a sequencer. Any bank that you want to output the names for should have this option checked. So the internals here you'll find checked. The M1 being an old style instrument, it can't handle the external Combi bank. Here you'll see the program bank is checked, the external bank isn't checked, and those will be the only two that are checked here. So if you were to output a Sonar name file or a Cubase name file, you would find that only these two banks were output to the file for use with the sequencer. This final section. Type is a text entry and will accept, I believe, up to 8 characters, and it defines the type of data and acts as, if you want to call it, a glue to the various drivers so that they can recognize that they are holding data of the same type. So you'll see that each of the combis has a type defined as combi, whether it's an individual combi that's being loaded or a combi bank that's being loaded. Here with the patch bank, external patch bank, and a single patch driver, all are defined as patch. Globals have a definition of global, sequences of seqall. You can use any text that you want in this area, but they should match up in order for Midi Quest to function correctly. Driver ID. Each driver needs to have a unique ID. If you are making these drivers just for yourself, you can start numbering at 16,000. If you plan to make these available to anyone in the outside world other than yourself, please contact SoundQuest and we will assign you a driver IDs for each of your drivers. These need to be unique and allow Midi Quest to correctly identify the actual type of data it's working with when the data is reloaded off disk. Link ID. The link ID allows banks and individual drivers to reference themselves. So you'll see here the driver ID is 86 with the link ID of 89. If you look at the Combi, you'll find that the ID for the Combi is 89 and the link here is 86. So when you've got a Combi bank and you ask to edit a particular Combi, Midi Quest says, the link is 89. That is where I go to create my editor, the Combi editor. If you're working with a Combi, the link going the other way is much less frequently used, but in this case, when you're working with a library and you say, I'm going to create, I've got a library of patches, I want to create a bank, here the driver looks at the link ID, says, there's my ID for my bank, I can create a bank if I find the driver with ID 93. Child ID helps glue the parent-child relationship together. So if you have a Combi, the Combi will have a child ID that references the bank that the names for the patches that it's referencing come from. There are actually two ways to do this. In this case, we're using a local ID, and if you look here, you'll see the local ID for the patch bank is 1. So the reference here is to 1, and it can go out and pull the correct names from the correct bank so that they can be displayed in the editor. Local ID works on the same concept as the driver ID, with the exception that it just needs to be unique within the instrument itself. So local ID isn't used very often, but you'll find that when it is used, each driver that has a non-zero local ID, the value is unique. You can look up more information on local ID in the online help. Multi-bank base. Within all of the banks, when you have an instrument, let's say a Trinity, you've got 4 Combi banks, you've got 4 patch banks. In order for Midi Quest to maintain the correct structure and organization of things, particularly in dealing with hierarchical editing and outputting of names to text files, this number, the banks have to be organized sequentially. So from an internal point of view, each of these banks contains 100 patches. From the user's point of view, this has a numbering of 0 to 99. This one is numbered 0 to 99. This one is numbered 0 to 99, and so on. Midi Quest needs to be able to organize these as a table of, say, 0 to 400. So this one has to be viewed as 0 to 99. This one 100 to 199. This one 200 to 299. And this one 300 to 399. So in order to do this, we need to add a base offset value that is just used internally to the program that allows this organization. So if we go and have a look at the Trinity, you'll see, whoops, I had the bank size wrong, I'm sorry. You'll see that this one is 0, this one has a base of 128, this one of 256, and this of 384. So within the total patch or Combi memory space, each bank is taking a unique area. We'll jump back to the M1. Directory. Each driver, normally each instrument has its own unique instrument folder where patches and banks and any kind of data you choose to mention is saved. We choose to structure the data storage that way, but each driver can actually have its own unique default directory where data, newly created, newly loaded data, wants to be stored by default. This is where you set that default. So under MQ data, the data here will go to the M1 folder with a data extension of PBK. You want to keep the extension unique for each of your drivers. Normally, we would keep the directory the same for each driver, but it's completely up to you. And lastly, you have an icon selection, and this basically indicates the general type of data that this driver handles. So here it's a patch bank, and this setting is what you see when you shrink down your studio window and look at each of the drivers. This icon corresponds to patch bank. This icon corresponds to an individual patch. And if we open up here, you'll see there's another icon for multi-bank, another icon for multi, another icon for global data, and so on. So all of these icons are specified using these selections here. Now in the lower area are all parameters you want to do your best not to use. These are all parameters from very early versions of Midi Quest. You'll see that most of them are disabled, and you can see them enabled if you turn off macro I/O. There they are. If you really want to know about this area, check the online help for an explanation. The last area, macros. There is a macro to receive data, that is transfer data from the instrument to Midi Quest. There is a transmit macro that is used to transfer data from Midi Quest to the instrument, and audition. You will only find audition macros in patch banks. If you look at an individual combi, an individual patch, individual global, and so on, you'll see they're all faded out. What happens here is when you select or click on a patch in the bank to audition it, this is the macro that gets called to send the data you've clicked on out to the instrument. The manual has lots of explanations and samples on how macros are used. I'll take a look at a couple of simple ones just so that you can get some basics on it, and they can range from being very, very simple to very, very complicated depending on what you need to do in order to get the data out of the instrument and into the program. This is one of the simplest macros you'll see, but it's used in many, many, many of the drivers. This first command here, S7 followed by a MIDI command, is basically saying set up a request. The request is going to be 7 bytes long, and it is followed by the 7 bytes. This is going to be your dump request, what you want Midi Quest to send out in order to get the data out of the instrument. Now, if the instrument doesn't have a dump request, obviously you can't enter one, but these days most instruments do. TR is transmit on receive, and what that says is my currently formatted message, which is this, I want you to transmit it, but not now. I want you to transmit it on the next receive command. This makes sure that Midi Quest is all set up to receive data before the dump request is sent, and ensures that there isn't a glitch or a mistake where the request gets sent out and the data is responded to, gets sent back from the instrument, and Midi Quest isn't ready to receive it. And here's your receive command. Midi Quest is expecting 14,179 bytes back. Now that's a maximum, and usually the file size, see, same value. And we've specified that this is fixed length. So Midi Quest can be smart. If a couple of bytes are missing, you're going to get an error message because Midi Quest knows that the right dump has not been received back. Now, if I were to uncheck fixed length, then Midi Quest here is going to accept any dump up to 14,179 bytes. And it will actually shrink back the data. If it receives 100 bytes, it will actually shrink the file size down to 100. And this most commonly happens when you're requesting sequence data, and the size of the sequence dumps can vary hugely from just a few bytes up to hundreds of thousands of bytes, depending on how much data is currently stored within the sequence area. Now, the transmit macro does the reverse of the receive macro. it wants to get data from the program out to the instrument. Now, here we've set up the header to format into the data. This here we're formatting in the tail, and then we go transmit. Now you might say, well, why do I have to format in the header? I receive data from the instrument, and so Midi Quest will already have the header and F7 tail set up. I don't need to worry about this. Actually you do, because if you ask Midi Quest to create a new bank or a new patch, that header and tail are just going to be 0. So the command FA60 basically says format in data. I want to format 6 bytes, and I want to offset the formatting of this data in at offset 0 from where my current data pointer is. Midi Quest works on a data pointer principle. So it starts off, the pointer starts off pointing at the very first byte in the data that's been allocated for the reception of, in this case, a bank. And each time it receives sysx data, that pointer is automatically advanced by the number of bytes that have been received. Now, in some cases, you may actually need to play with the position of this pointer in order to make the reception of your data work correctly. So here we're allowing a reference to where the pointer is, because we might want to say, oh, well, I want to format in the following bytes into offset 100. So I could type in a 100 here. Normally you'll see it set as 0, and there's the header for sending out your Combi bank. We set the X variable, MX. M stands for a math operation. X is a variable. You'll see that there are 4 temporary variables called W, X, Y, and Z, as well as over 2,000 permanent variables that are more frequently used within patch editors, but they are available to the macros as well. Normally in macros you'll see the use of temporary editors, temporary variables. So 247 is the equivalent of F7, or the end of sysx terminator, only this is a decimal value. So we set X to that. We format X into the very last byte, 14178, and then we transmit all 14,179 bytes down to the instrument. Midi Quest is modeled on the C language, and for those of you who are familiar with C, when you create an array, the array is referenced. If you say create an array of 8 bytes, the first byte isn't numbered as 1, the first byte is numbered as 0, and you have bytes 0, 1, 2, 3, 4, 5, 6, and 7. Midi Quest maintains this, so we refer to offsets as 0, 1, 2, 3, 4. So you would never want to format in, F is format, so format the current contents of X into this offset. You would never want to format into byte 14179, because that's actually beyond your memory area. Let me say one other thing here for you to keep in mind, and it's important. The drivers expect you to maintain data integrity. Midi Quest, if you were to write in the value 144,178, Midi Quest will believe that blindly, and it will write in, put the value 247 hex F7 into an offset of 144,178 bytes away from wherever the current pointer is. Now that kind of mistake will probably mean you're writing into invalid memory, and that will cause Midi Quest to crash. It's the way Midi Quest works. You need to be careful with the values. You need to be careful with your offsets. Save your data frequently, and watch to ensure that where you are writing data is a valid location that you can actually write into. The audition macro. When you click on a patch, Midi Quest will take that patch data and send it to this macro so that it can be output. Now, many instruments, and I'll pull up an example here, you create a bank simply by looping and collecting all of the patches in the loop, and so everything is already nicely formatted. Let's have a look here. So you have with this instrument, you're actually able to load the data with one command. An output, here's the loop. You do 128 loops, sending each patch once. So here, in order to audition, you set up one command. This just ensures that the instrument is in the correct mode. Transmit that. This is a delay. Midi Quest does its delay timing in hundredths of a millisecond. So if you want to work in milliseconds, it's actually 50 milliseconds, and then just add 2 zeros. Then what we're doing, we want to ensure that there's a valid header for the actual voice data that you're sending out, or patch data. So there's your patch header. With this instrument, it's necessary to separately format in the channel information. K is a checksum command. So this generates a checksum. It calculates from byte 5 for 260 bytes, does the checksum and stores it in byte 265. Add in the tail 247 and transmit the data. All of the macro commands, there are several hundred of them at least at this point. They're all covered in the online tutorial. You can look through them. Some of them are very simple, like T is transmit, but there are some other macros that do some extremely complex work. Hopefully I've covered this well enough for you. You probably, if you're trying to learn how to do drivers, you probably want a couple of suggestions for you. Hopefully we have done drivers for an instrument from that manufacturer already. Manufacturers tend to have a style. Roland does their SysX one way, Yamaha does their SysX one way, Korg does their SysX one way, but each of these ways is slightly different. If you start off, if you're trying to develop drivers, develop an instrument, look to existing drivers for that instrument first as a starting point, because odds are the way the company does things will be very similar for a similar instrument. The Triton SysX is very similar to the Trinity SysX, and the Trinity SysX is very similar to the SysX from the Korg instrument that came before that. Look at a range of drivers. If you're doing work in macros, SoundQuest, email tech support. They will help you if possible. If you can get them the information they need, they'll give you some hints. And definitely there's a lot of writing has been done in the online help covering off all of the macros, what they do, examples, and so on. So make use of those resources as well.